Our climate crisis is making demands. It demands global cooperation. It demands effective action that doesn't settle. It demands life to be made better for all people. The crisis is challenging us not to just survive, but to make a better future. Perhaps no one has demonstrated the power and possibility of Passive House than our keynote speaker, Managing Director of Archetype, Jonathan Hines. Jonathan, welcome.
Okay, thank you very much indeed. It's great to be here. Just get this adjusted. Okay. Thank you. So I was honoured to be asked to come to Denver to speak at the conference. I was then humbled to find I was giving the keynote address. And then I was somewhat horrified to be given the subject, Dream Big, Passive House, the platform, not because I couldn't talk about it, but because I had to rethink the normal talks I just churn out. So I was really intrigued with the subject, and it gave me the chance to reflect on my own Passive House journey at Archetype over the last, Archetype's journey is nearly 40 years old now, but Passive House for the last 15 years. So I'm going to take you on that journey. I hope you'll find it interesting, and if I manage to inspire you to dream big, then hopefully you'll succeed in what Ken asked me to do. So I'm going to start off right at the beginning I'm going to just tell you a little bit about Archetype first of all. We're based in the UK. We have offices in Edinburgh, Hereford and London, and we've been specialising in sustainable design for 39 years now. We're 40 next year. At the heart of what we've been doing for a long time now is Passive House, using natural materials, focusing on low embodied carbon, working across all sectors. A large part of our work is education, but working in nearly every sector in the UK. So I'm going to take you back to the roots of Archetype. We actually grew out of the pioneering work of the Swiss architect Walter Siegel, who developed a really radical way of building, which enabled ordinary people to build their own houses without any previous building skills. And it was that sort of buildability and simplicity of construction which I think has underpinned everything that Archetype's done and has enabled us to achieve Passive House at sort of economic costs. And I'll talk more about buildability and simplicity. But it was a really radical, simple way of building where you just have to, if you can learn to measure, drill and cut and put a bit of welly into it, then you can build your own house as a group of people. Really inspiring for me as a young architect in the early days of Archetype to be working with people self-building their own houses to incredible quality and standards. And for me as a young architect, it was a really humbling experience to realise that you couldn't just do a drawing and pass it to a builder and expect it to be done right. And if it wasn't, just tell them to redo it, because the self-builder would turn around and say, well, I don't understand your drawing, show me what to do. And you had realised you really had to begin to understand not just what you wanted, but really how it could be built. And then one of my very first buildings in 1991 was this little visitor centre for a wildlife organisation in London. And they wanted a Siegel-type timber construction. They had a very, very tight, small budget, and they wanted a building to be as sustainable as it possibly could. And I'm really grateful to them because it forced us to think really hard about what we could spend the money on and keep the building really simple, make the shape and the form and the orientation of the building do all the hard work to moderate its climate without the need for a complicated M&E systems and all the kit that was normally put into buildings. So we had a very simple building with a roof tipped up to the south, a veranda to shade out the sun that would overheat it, and then a very simple natural ventilation where we could open high-level windows and low-level windows to cool the building in the summer, but to gain maximum warmth from the sun in winter when it would be useful. So this was a really, really simple building. It was the very first building in the UK to use recycled newspaper insulation, using a sort of breathing construction, organic paints imported especially from Germany for the project itself. But most importantly, a really simple shaped building, thinking about its form and orientation, to do all the hard work in environmentally controlling itself. And again, that runs through our sort of approach all the way through. So I'm next going to show you 3 key projects that we did between 1995 and 2005, which really took us from where we started through to discovering Passive House and then embracing it. The first is a building that we were asked to design for the Hornham Museum, which was a really amazing place in South London. And they had this old tennis court site next to their museum building where they wanted a demonstration building. They called it the Centre for Understanding the Environment. And they'd seen our Seagull buildings like the one I just showed you. And they wanted something like that, but on a much bigger scale, that could operate itself automatically without needing, as the previous buildings needed people to open and shut windows and all the security that went with that. They wanted it to be automated, but simple and efficient. So we basically took the idea of that post and beam simple timber construction, but took it up to a huge scale where the columns and the beams would not only hold up the building, but would also act as a ventilation system, a sort of passive ventilation system to draw cool air from underneath the building into the building, up out through the column chimneys at the top. Could all be controlled with a simple building management system. But the other thing that this did was enable us to integrate services with structure and prefabrication, because they wanted this building to be built, had to be built incredibly quickly, had to be built in 8 weeks from the time they had the site available to opening. And they also wanted a building that could be moved in the future to another site, because they just saw this as a temporary installation. So we had to design a building that could be highly sustainable, could be built quickly and could be moved to another site. So we came up with this idea of these big prefabricated structure that acted also as the services. It was probably the most stressful 8 weeks of my life getting this thing built, but we managed it. Health and safety, don't look at this guy on the top of the ladder there. Or the other guy just behind him on a little bench on top. Anyway, there were no accidents in the construction of this building, and it was indeed up and running and opened in 8 weeks. The reason I'm showing it to you, because for me it was a really seminal building where we really, again, were thinking about form and orientation, but integrating it with structure and services. Nowhere near Passive House. It was definitely a key building on our journey towards it, that type of integrated thinking. The next project is a co-housing scheme, which I'm showing you because it really brings to the fore the sort of social side of our work, the importance of working with communities and taking communities with you. So this was a scheme. I know there's been quite a few co-housing schemes here in the US, but we discovered it from people in Denmark, where it's very popular. And the idea is, rather than a social housing provider building houses that they rent, or developer doing houses for sale, the people who are actually going to live in the site actually form their own development company, employ architects, raise money, and build out the project. But what's really interesting here is that they demanded high standards of sustainability. They wanted low energy houses. It wasn't having to persuade a developer. They were the developer telling us that's what they wanted. But really importantly, they also wanted a scheme which was highly social. So instead of all the houses on separate plots, they wanted shared gardens that they all shared together. They wanted a common house at the heart of the scheme where they had communal facilities. And it creates a character of living which is vibrant, and the cars are kept away from the site. It's all pedestrian. The children are completely safe and can play anywhere. The gardens have private areas, but they're open communally. They own the whole site as a group, and then leasehold individually their individual houses. So it's just a remarkable process of working with ordinary people to build a very special place. But the message here, again, is working with communities. But when you work with communities, when you open up to people, they demand sustainability in the way that politicians and professionals and developers often don't. And then the third key project is St Luke's Primary School. which was a key step in our journey towards Passive House, because we really here were focusing on improved insulation, on getting rid of thermal bridges, on improving air tightness, triple glazed windows, but we were still big believers in natural ventilation, and we didn't like this idea of mechanical ventilation. But again, it brought together for us the sort of social side and the environmental side, because we rethought what a school is and moved away from corridors and classrooms and created shared spaces of which classrooms opened. This very much came out of consultation with the school, where they wanted to create, it was a very deprived part of Wolverhampton City, and they really wanted to create a place where children could learn to develop and fulfill their potential, not just by sitting rows in classrooms, but by collaborating in groups and different activities. So you can see here, we developed a very interesting section which runs through the entire shape of the building to create a whole series of different spaces which would bring daylight into the heart of every space, would allow natural ventilation through every space, and basically bring a school to life and real focus on the quality of natural materials that children would touch and feel, and the quality of light and air in the building. And it was a very, very successful building in many ways. However, we then did post-occupancy monitoring, and people loved this building, and it works very well, everybody thought, in many ways. But we had heard about the performance gap, and we wanted to test our own buildings rather than just believe that they were good enough. And when we did this, we were horrified to see the CO2 levels that we were getting in the classrooms. The three different colours there, the blue is winter, the green is autumn or spring, and the orangey colour is summer. Now in summer, it's not too bad as you expect, because the windows can be wide open. But in winter, we were getting CO2 peaking at 3,000 to 4,000 or 5,000 parts per million, which is truly horrendous. And so we were horrified to discover this, but actually it's not uncommon, and it's not as bad as some other schools that we also monitored, of all sorts of ages, new and old, often getting above 5,000. So it's just extraordinary to realise how bad the air often is in our buildings. So we basically determined to find a solution to this, and it just coincided with a time when Nick Grant, who some of you know very well, who's one of our very close colleagues that we work with a lot, had been over to the Passive House conference and came back and started talking to us about this standard that he was very sceptical about, but discovered that it actually worked. And we didn't really believe him either, but started to look into it. And the more we looked into it, the more we realised that it offered a solution. And when you look at how big the gap in performance is, it is extraordinary. So this is some data from many years on that we've used to convince people subsequently about why Passive House. So SBEM is the modelling that's used for building regulations for non-domestic energy predictions in the UK. And this is a secondary school in the city of Edinburgh, what they predicted at building code stage and what was actually measured in reality. So an extraordinary 4.7 times as much energy, and the gas 23 times higher. I mean, that's just an order of magnitude of error, which is extraordinary, but is not uncommon. And then one of our own Passive House buildings, built many years later, predicted in PHPP actually what was achieved in PHPP year on year on year on year. And our client at this building said, this is the only building, this is a university, this is the only building we've ever had which performs exactly as it should. Now, surely every client should expect every building to perform as it should. If we bought a new car and it did 10 miles per gallon when it should do 60, or the air conditioning unit went hot when you want it cold and the opposite, you would take it back. But buildings do that all the time. It's quite outrageous and scandalous. And when we go back to this graph that I showed you just now from our primary school, and monitoring a passive house school we built a few years later next door, you go from that to that in terms of CO2. And when you get the head teacher saying our children are more alert, they concentrate better, that's what it's all about. Energy is important, of course, but actually for children to be able to study and concentrate. We can all remember, I'm sure, the Friday afternoon English lesson where you struggled to stay awake. You thought it was a boring teacher, it might have been, but it could just as well have been the CO2 was so bad you couldn't possibly stay awake even with the most interesting teacher. So, Passive House, we quickly became intrigued and converted to the fact that it could offer us a solution to this sort of performance gap that we were horrified to have discovered. I think we were most interested by the fact that it was not just an energy standard, but it was first and foremost a comfort standard. But underpinning all that being a quality standard, which is what guarantees that it will work. The science is spot on, but the certification and the quality underpinning is really what makes it the difference. And as an architect, there's nothing else that I've ever had to do in my career where my work is so thoroughly checked externally by an independent person. And then the same for the contractor, to have to gather the evidence is just so different, and it's what makes it work. So for us, Passive House became something that we knew would guarantee that the building would actually perform as designed. And why, as an architect, would you ever want to design a building which doesn't perform as it's designed? But we do it all the time. So it's a way of making sure that it does perform. It eliminates the performance gap, which is critical. It's reducing energy by design rather than, as so many other codes and things doing, just offsetting carbon by add-on features and renewables. It's reducing running costs, and in housing, that's reducing fuel poverty, as we call it in the UK. And because the systems and controls can be simpler, and the building fabric is more robust because you don't get air leakage and moisture and condensation, it minimises maintenance costs. So ultimately, it's offering a really robust way to meet zero carbon targets. There are, however, as we discovered, and are still finding, many years on, many challenges in achieving Passive House. I mean, it's so blindingly obvious, you wonder why it can be so challenging. But there are still myths out there and misconceptions. Clients still have to be convinced. It's tricky to get procurement right and do it at an affordable cost. And there is a staggering lack of building physics in our profession and across our industry. And there's a real need to upskill design teams and contractors in order to overcome that. And obviously the biggest one here is cost. Does it cost more? And as you'll see from the projects I'll show you in a minute, my belief is that it can cost more, but it doesn't have to. Cost is a matter of priority. So if you've got a budget and one of the key thing you're trying to achieve is Passive House, then you'll have to be very wise about how you design the building. It's possible to build a Passive House at the same budget as a non-Passive House. It's possible to build a really expensive Passive House. It's also possible to build a really, really expensive not Passive House. So in my view, price is a matter of priority. What are your priorities? And when an architect says to me, oh, sorry, we couldn't afford Passive House, and you look at his building or her building and you see a really expensive fancy cladding or a strange corner feature, and I think, well, you could have afforded it, you just chose not to. So Passive House and price, it's all about priority. Now, there are some things which cost more. Obviously, triple glazed windows, MVHR can be more than you would normally do, but there are other things which save money. It encourages a simpler form. If you create a building with 4 corners, that's going to be more efficient and cheaper to build than one with 36 corners and funny shapes. I dread to think what the form factor of the Denver Art Museum spiky, pointy building is, but that's a classic case of a building which must have been expensive, but could have been simpler and could have been Passive House. So the challenges are, I think, in achieving this, Architects, generally, we like complicated things, don't we? And if we can make a building more complicated, we will. So we need to try really, really hard to constrain ourselves and create simple buildings. M&E engineers, service engineers, they love complexity too. They like pipes, they like wires, they like systems, they like add-ons. And they too have to retrain themselves to think in a simpler way. And then quantity surveyors, cost consultants, and contractors, they all will price the risk, the perceived risk of something that's new and unknown to them, and you have to overcome that. So we have to overcome our instincts to design complicated things, and we have to overcome our worry about the risk of something new. But we can do that, and that's what we have to do. So I love jazz music, and I think this quote from Charlie Mingus really says it all. Making the complicated is commonplace. Making the complicated simple, that's creativity. So making the simple complicated, anybody can do that. Making the complicated simple, that's creativity. And that's what I think we need to do. And that's what Passive House offers us the opportunity to do, encourages us to do that. So we need to change the culture of how we design. And I think too often, I don't know how it works here in the US, but in the UK, design is often a linear process where the architect comes up with a vision, you pass it down the line for the engineer to make it stand up and fix the services, you pass it on to the builder to make it stand, to actually build it. And each person is passing responsibility down the line and not worrying about what's happening. With Passive House, you have to think in an iterative, cyclical way, so that you think about the form and the orientation, you optimize that, you develop the facade design and the fabric construction, the MEP services, and then you go around again and optimize and refine, and the PHPP helps you do this as you're designing. The whole team needs to work collaboratively together in a cyclical way rather than in a linear way. And as you do that, you start to create a building which is going to work, which is cost effective, and is buildable. And you're using the PHPP, as I'm sure you're all aware, to gradually bring the heating demand down from your first effort, which might have been at 30, change this, change that, tweak that, and you gradually get it down to under 15. I'm talking kilowatt hours per square metre. I don't know what it is. Okay. And at the same time, you're working hard to keep the overheating below limits. So that's what you do. So I'm just going to take you through projects that have helped our business go from our first Passive House in 2012, 10 years later, to 80% of our work is Passive House or Benefit. So these are the very first buildings, the schools we did. The client had a standard budget and said, you can do Passive House if you want. They didn't ask for it. We suggested it. But as long as you do it within the budget, and we achieved that. They could see how well it worked. And they came back to us 3 years later and said, well, our budget's reduced. Can you now do a Passive House for a reduced budget? And we did. But with no compromise to the quality of the architecture. We then did this building for the University of East Anglia, which combined achieving Passive House with BREEAM Outstanding and a sort of really big focus on reducing carbon with thatch cladding and timber construction. And it's been open now for 7 years, and every single year its energy has been under 15 kilowatts, spot on, performing exactly as it should. This was the first Passive House secondary school in the UK. And so it's a much bigger scale building for us, and quite challenging in terms of the complexity of what's required in a secondary school. But again, we managed to achieve this, and a building which does not compromise, I think, on architectural quality by being Passive House at all. In fact, quite the opposite. And achieving, in terms of total energy consumption, a 69% reduction on typical benchmarks in the UK. That's overall energy consumption. And then we're also now moving into Benefit. So this is the Cambridge Institute of Sustainability for the University of Cambridge. existing 1930s building where they wanted BREEAM Outstanding, Well Gold, Enefit, and every standard they could possibly think of. And it was quite a challenging building to do, but we managed to we modeled different options and actually got doing the building to Enefit is achieving a 78% whole life carbon emissions reduction from business as usual. One of the really interesting things here was the windows with typical sash windows, which are really difficult to make energy efficient, but actually cut out a huge amount of daylight. So we managed to work very hard to persuade the planning conservation officers, it's a very sensitive architectural area, Cambridge, to go for fully frameless, glazing, which was hard work. So you need to dream big and persuade hard. But the big impact there was obviously saving energy, but improving daylight massively. And I think the finished building looks really cool on having those very, very simple windows set back in the facade there. And the quality of spaces we managed to achieve inside, very good too. So the next stage in our development was opening an office in Scotland. We didn't do that because Scotland was some passive house mecca. There was very little passive house happening. But we could see there was potential there with the very ambitious targets that Scottish Government were setting for climate policy, really more ambitious than the rest of the UK. And I then moved there and started talking to people and worked with the Scottish Futures Trust to fund schools in Scotland to develop a mechanism which set an EUI target for all energy and tied it to funding, so that for a local authority to get funding to build a new school in Scotland, you now have to achieve this target every year for 25 years, and you get your funding as a revenue payment each year over 25 years. So overnight, it meant that any local authority in Scotland wanting to get funding from the government to build a school needed to achieve this. Now, they could achieve it any way they wanted, but actually, we could tell them that passive house would guarantee that they would achieve this, because we'd expect a passive house school to come in at about 50-something, safely, well under that metric. And so overnight, that transformed school delivery in Scotland to the extent that of the 37 new schools currently being designed or built, 21 are being done to certified passive house, another 4 to principals, and 12 are trying it in different ways. Well, good luck to them. And then the other really exciting thing that's happened is that we held in Scotland a citizens' assembly, which was 100 citizens from around Scotland came together to explore how climate change could be addressed fairly and justly in Scotland. And they looked at lots of different areas, but in terms of building, interestingly, the citizen recommendation was that passive house should be adopted, and 97% of them supported this. It was then taken on by one of the Scottish members of Parliament to propose a bill to actually introduce it. That went out to public consultation, got 93% support. It's now been adopted by Scottish Government, and we're currently in the consultation phase with a view to getting it into regulations by the end of 2024. And all of that, the schools and passive house into building regulations, has really had a big impact on changing the culture, addressing this issue of the skills gap, a huge amount of training happening. We've got this amazing training facility called BEST, where they're doing a huge quantity of training in passive house and retrofit, and it's all being funded by Scottish Government. So that, in terms of dreaming big, was just me and a few other people knocking on doors, talking to people, and changing a country from not doing passive house to doing passive house at a big scale, and at the same time creating a new market for architects and engineers to do buildings in a better way. And we've just finished the first passive house primary school in Scotland, which was finished in June and is occupied now. And we're getting really good feedback from users and good energy metrics from our monitoring. And then this is currently on site. It's a big high school, which typically in Scotland also includes lots of community facilities. So it's quite a complex building, a big school of this size, but also has a library and a swimming pool and lots of sort of complexity of layout. And yeah, there's not time to go into all the metrics, but we've got an overall form factor of 1.7. And you can see afterwards all the different levels of insulation and glazing ratios and heating demand. And it's currently on site. It's a big steel frame building. Now, steel frame is really, really challenging to do passive house. And this was an example of us having to respond to the market, which builds schools in steel frame. We just couldn't persuade anybody to do it in timber or in concrete. It just doesn't happen in the UK. Everything for schools pretty much is steel frame, although we have got a swimming pool in CLT, solid timber construction. But the first building I showed you was steel frame, and we managed to get the airtightness down to 0.5 something, which people said would be impossible, but it just shows that passive house is construction blind. You can build it with anything, and that's one of the great things about it, even steel frame. And then finally, City of Edinburgh came to us and said, well, actually, deciding to do all our schools passive house, that was the easy bit. What about the hundreds of buildings we've already got? How do we tackle them? And we said to them, well, adopt the same rigor, model them using PHPP, and use PHPP to guide you as to how you could retrofit that building. It may not be, in all likelihood, that you'll be able to afford to do every building benefit, but understand the building by analysing rigorously using PHPP, and then use that PHPP to model different scenarios, different levels of intervention. And so we've now done 12 buildings for the City of Edinburgh and extrapolated that across our entire estate of 300. We've now done that we've done about 30 buildings for a quarter of all the local authorities in Scotland. It's a huge body of data, all using PHPP. They're all sharing data with each other. And they can all use that to make informed decisions about how to retrofit a particular building or how to manage and improve the building over time. So if they're changing the windows, they know what to do now and the roof in 5 years' time. So you can stage over time, or you can retrofit now to whatever standard you think is right in terms of cost, carbon and energy, but strong in the knowledge that your analysis is rigorous because you're using PHPP. So we call it the NFIT Informed Retrofit Plan, and it's that rigor that we know works that's giving real credence to this analysis. So, just in conclusion, I showed you one of my first buildings I did, and the thinking that came from that of simplicity, of using the form, helping the building to do all the hard work rather than relying on add-on complexity. And I would encourage you all to think simple. Remember Charlie Mingus's quote. And I just want to show you a couple of other examples of how that thinking of keeping it simple but dreaming big has helped us to do some interesting things. So we were asked to do a new archive and record centre. So this is a building that keeps very precious archive material that could be hundreds of years old at very constant temperature and humidity in order to preserve it. And typically these buildings are rammed full of kit, trying to close control temperature and humidity to keep it stable, inevitably failing because one thing goes wrong and everything goes out of kilter, and then temperature, humidity, one or the other or both goes haywire and the materials get damaged. So we proposed, let's do it as a passive house. Make a very, very simple box, airtight, well insulated, and reduce the kit down to the very, very minimum you possibly need just to keep temperature, humidity. This is not full of people. They go in there occasionally to access the archives, so you don't need the same levels of air as you would in an occupied building. Now, when we were designing it, we were arguing that this would work, and our service engineer said it'll never work, you need to have all this kit. The client was kind of convinced but was worried, and at one meeting the client said to us, are you sure this is going to work? We're investing a lot of money here. And our colleague Alan Clark, who some of you also know, quickly said, "Don't worry, we're designing an iceberg." And we persuaded them we got rid of the M&E engineers because they were too sceptical, got new engineers in, kept with the client's confidence and built the building. And the proof is in the pudding, because if you're an archivist, this really is the most exciting graph you'll ever see. Now, one of the things that I found interesting over the years is we've had a lot of criticism, skepticism from the architectural community that Passive House makes you design boring boxes. You know, it's all very well, all this stuff you're talking about, but your buildings are quite boxy, they're not really architecture. But hopefully you've seen from what I've showed you that I think that's wrong, and I hope you do too. But ironically, when we designed this building, which really is a box, which is another archive building for the Imperial War Museum, in a really it's an amazing site, but we just created a really, really simple box. In the architectural press, we suddenly got lauded for finally finding an architectural language that matched our sustainability credentials. And we're thinking, you've been telling us we designed boxes, now we designed a box, and you're telling us we've created architecture. So. But what's great about this building, again, it's for very, very precious archives for the Imperial War Museum. It's 5,000 cubic meters of building, which I think is 180,000 cubic square feet. And that is the M&E that it has in it. One package chiller, one cooling coil, one domestic size MVHR, and 9 domestic vents. And it's creating a building with phenomenally low energy consumption and phenomenally stable, that horizontal graph, which everyone is really excited about. So dream big, always challenge your fellow peers, your consultants, your clients. Challenge them to dream big, but keep it simple. So this little diagram, I think in the past, buildings were very simple. Windows you could open, little coal fire, but they were energy consuming, uncomfortable and unsustainable. In the present day, we've got obsessed with complexity of systems, of shape and form, of using carbon offsetting to fool ourselves that we're achieving sustainability. Passive House offers simplicity, a much simpler way of building, which is energy saving by design, which is comfortable by design, and ultimately, therefore, is truly sustainable. Thank you very much.